Hi, my name is Clayton Turner. I'm a research engineer here at NASA Langley Research Center.
Hi, I'm Kaylee. I'm Catherine. Nice to meet you. We're trying to solve a problem, and we need to know how light can travel in a wave and a straight line at the very same time.
Well, perhaps I can help. I do a lot of research with light on this laboratory.
That doesn't look like a laboratory. That looks like a plane.
Well, this is NASA Langley's 757 Ares research aircraft. Come on board.
Do you fly this plane?
No, I don't fly the plane. We use this plane to conduct research. In particular, we use light to study the atmosphere.
What's that?
This is a spectrometer. Let's go in the back and I'll tell you a little bit more about it. This is a spectrometer. It collects light and sorts it by wavelength.
Can you tell us more about light as a wave in a straight line?
Yes, light can be thought of as particles called photons that travel in a wave-like pattern.
But we also learned that light can travel in a ray, which is a straight line.
Yes, a simple model of light is called a ray or straight line. The arrow at the end of the line shows the direction that the photon is traveling in.
But what about a wave?
Light, or electromagnetic radiation, is a form of energy called radiant energy that has an electric field and a magnetic field. If you take the simple model shown on the screen and add an electric field, it would look like this.
That looks funny.
Look at the ends of the electric field.
It looks kind of like a wave, but why are the lines different heights?
First, let's look at a model of the wave.
He knows magic too.
The top of the wave is called the crest. The bottom of the wave is called the trough. The wavelength is measured from the top of one crest to the top of the next crest.
Do different wavelengths mean different things?
Yes, color is typically described by the wavelength or frequency. For visible light, violet has the shortest wavelength and red has the longest.
So what is frequency?
Frequency is the number of times the crest of the wave passes a stationary point.
I get it. So the shorter the wavelength, the more waves would pass a stationary point, and that would be high frequency. So violet is high frequency, and red is low frequency. Is there anything else we should know about a wave?
Yes, amplitude.
Why is this important?
The amplitude is half the distance from the crest to the trough. The higher the amplitude and frequency, the higher the energy.
Thanks for letting us go on the 757. We learned a lot.
I really hope this information helps you solve your problem.